Hey everyone, welcome to the final video in our series, and we are finishing off finally with sketching parabolas. Now, the last thing we're going to do in this topic is to bring together everything we learnt from the first half with our solving quadratic equations, as well as sketching parabolas, to really try to draw up some thorough parabola sketches here. And we are going to do this by what we call using intercept form. So you may remember back in linear relationships, we started with writing up the tables of values and learning about different types of concepts. And by the end of it, we were able to figure out that, well, if we just find an x-intercept and a y-intercept and join the dots, it's going to give us a pretty good idea of how the line on the graph is going to look. We're doing a similar thing with sketching these types of parabolas, and when we actually sketch these, we are going to be finding a bunch of different things. So we're going to have the two intercepts, x and y. We're going to find an axis of symmetry, a turning point, and then have a really nice clear drawing of the graph with all of the key features labeled. Now let's get straight into it. You may have noticed in all the different parabolas we were looking at, we noticed that in terms of intercepts, they sometimes changed, particularly how it relates to x-intercepts. So sometimes we had these parabolas looking like this, or like this. These types of parabolas, if we look, each of these have two x-intercepts. So I'm going to write down, these had two x-intercepts. We also noticed there were a couple that looked like this. Particularly when we were doing our starting with horizontal translations, we had some that looked like this. That's a bad looking parabola. Like this, or like this. These, if we count, they had only, that's not drawn very well. That's just meant to be one intercept here. Let's actually draw that once more. Okay, that's better. These guys only had one x-intercept. And we also had a couple of these when we looked at our vertical translations. We had things looking kind of like this, in which you can see the graph actually never meets my x-axis. So these types of graphs had no x-intercepts. So we didn't really talk about this too much, but the number of x-intercepts we have on our graphs really depend on the equation and what the parabola equation is actually doing. And oftentimes, when we want to make a really nice sketch, a nice detailed sketch, we need information about not only the y-intercept or the turning point like we did in the previous video, we also need information about the x-intercepts. So for the first part of this video, we are just going to revisit something we did at the start of this topic with our quadratic equations and solving these. We are going to just practice finding our intercepts, because this carries over a lot to what we're going to be doing in this video. So for each of these examples, y equals x outside of x plus 1, and another one down here, y equals 2 outside of x plus 2, x minus 3. for both of these, we want to find both the x and y intercepts. So for each of these, let's start with the y-intercept. And we know our y-intercept happens when x equals 0. So therefore, this first one, I'm going to substitute in x equals 0 to find the y-intercept. So this thing is like saying 0 times 0 plus 1. And anytime we multiply by 0, we are going to get 0. So our y-intercept here is going to be 0. Now, that's usually the easy part. When we have to start finding x-intercepts, this is where it gets a little bit tricky, but there is a lot of carryover from what we learnt at in the first half of this course. Alright, now our x-intercepts, we learned this from linear relationships, they happen when y equals 0. So instead now of substituting 0 in for x, we are going to do it for y. Now, if we remember back to the start of this topic, we used something called the null factor law, which told us that because this is a multiplication, we can find solutions when this thing on the right equals to 0 based on the values for x that make either this expression or this expression 0. So here, we are going to have a couple of cases where this equation can be equal to 0. Now, we want to find examples when x plus 1 equals 0, this expression on the right, or when x equals 0 on the left. Now this first one here, if we remember back to null factor law, this is a solution to the equation, because subbing it back in, we get 0 times 0 plus 1, and that gives me 0, because so long as one of these expressions is 0, we're always going to get a solution of 0, because we're timesing by 0. I know I said a lot of zeros there, but the null factor law just means that as long as one of these factors, one of these expressions, is 0, we are going to get a solution of 0 to the equation. Now, this other one here, we want to solve this equation, so I'm going to subtract 1 from each side to give me x on its own, and I'm going to wind up with x equals minus 1. So what that means is that when x equals minus 1, well, this guy here is going to be minus 1, but when we substitute minus 1 into here, we get minus 1 plus 1, which means that one of the factors, this one here, is 0. So I'm going to get a solution of 0 to the equation here. So these are my intercepts. So I actually have now, using the quadratic equation solving we did way back at the start of this course, I now have a tool for finding x-intercepts of my parabola. And my y-intercepts I get in a slightly easier way. I just substitute x equals 0. But to find x-intercepts, I need y equals 0. So I need a type of quadratic equation that we were exposed to at the start of this course, where we used the null factor law to actually solve this. So that's the first question done. That means this parabola, when I end up sketching it, will have 2 x-intercepts, because there are 2 solutions to my quadratic equation. Now, what about this one? So first of all, for the y-intercept, we're going to set x to equal 0. So that means I'm going to get y equals 2 outside of 0 plus 2 and 0 minus 3. So this means that to find the y-intercept, well, all of these things are timesing together. So this thing here is going to be 2 times 0 plus 2 gives me positive 2, times 0 minus 3 is negative 3, and that gives me negative 12 as a solution. And for the second part, where I'm finding my x-intercepts, I need to set my y to equal 0. So I'm going to get 0 equals 2 outside of x plus 2, outside of x minus 3. Okay, now I want to solve this equation here. So to make this easier, this 2 is not really telling me anything new about my intercepts. So I'm just going to divide through both sides by 2. Because my left-hand side's not going to change. 0 divided by 2 still gives me 0. And I have a nice little binomial product here, which will allow me to use the null factor law. So I want values for 0 that give me either this whole factor to equal 0 or this whole factor to equal 0. And I can find that by setting up 2 little sub-equations here. So I want a case where x plus 2 equals 0, and I want a case where x minus 3 equals to 0. Now, because we've done a lot of this, I'm going to just rush ahead. So to solve this equation, I'm subtracting 2 from each side. To solve this one, I'm adding 3 to each side. And that's going to give me x equaling to minus 2 here, and x equaling to positive 3 here. So that means I have, once again, 2 x-intercepts for my equation. Or for my parabola, I should say, because now we are applying these equations to our parabolas. All right, now this brings us to the actual sketching of parabolas. And remember, now we are finding a lot more details about these parabolas, which are going to let us make some really nice, hopefully more detailed drawings. So in my first question, I want to find a bunch of information about this parabola here. I want to find the intercepts, I want to find the axis of symmetry, and I want to find the turning point, and then finally sketch. Now, in this particular form, this doesn't tell me anything about eventually when I want to find both intercepts. Remember, when we factorize these quadratic equations at the start of the topic, we wanted to get this guy over here as a binomial product, because the binomial product, or just any product equaling to 0, allows us to use the null factor law. So we want to first factorize. The first step is always going to be to factorize these quadratic equations, because we want them in a product form, sort of like up here. This product form allowed us to actually solve for the x-intercepts, which is, at this stage of the course, going to be quite important. So I can see there's a common factor in both x squared and 2x of x. So I'm going to pull that singular x out the front. So x goes into x squared x times, x goes into negative 2x, negative 2 times. Now I have my nice expression of my quadratic and my equation of my parabola, which is going to allow me to find my intercepts as well as my x and y intercepts. So first we want to find the y intercept, and we get this when x equals 0. So substituting 0 into here, I get y equals 0 times 0 minus 2. And that just gives me 0 as my y-intercept. So my y-intercept is at the origin. It is right in the middle of my parabola. Okay, of my xy plane, sorry. Okay, now for part B, we want to find the x-intercept, and this happens when y equals 0. So putting this in, I get 0 equals x outside of x minus 2. And using my null factor law now, I can figure out what my x-intercepts are. So the first case is going to be a very easy one. That's just when this guy here equals 0, or when x minus 2 equals to 0. So to solve this equation, I'm just adding 2 to both sides, which gives me that x equals to 2. That's my other intercept. So I have 2 intercepts here. All right. Now, before we even go any further, let's just paste in our grid here. Now, I have, no, we're not going to do that. Let's draw up a grid, a blank grid, because now we're not doing transformations. So I have a y-intercept of 0, and I have an x-intercept of 2. And I also have another x-intercept of 0. So we want to find, well, what's my axis of symmetry going to be? Well, my axis of symmetry for my parabola is going to lie somewhere, because remember our parabolas are symmetric. So there's going to be a line right in the middle of these two x-intercepts, and that is where my axis of symmetry and also my turning point is going to lie, right in the middle. So how can I find the middle of these two numbers, 0 and 2? Well, we looked at, in a different topic, a strategy for finding something in between two numbers. We can do this by averaging out these two numbers here. So for part C, my axis of symmetry, so it's going to be a vertical line. So it's going to be in the form of x equals something. And my x value, where the axis of symmetry will lie, is going to be the average of 0 and 2. And I find the average of two numbers by adding them together and dividing them by the number of numbers there are. So here I have 1, 2 values, so I'm going to divide by 2. So this gives me 2 divided by 2, which gives me 1 as an answer. Okay, so that means my axis of symmetry is going to be here. All right. So I have my axis of symmetry. Now the next part is I want to find my turning point. Now my turning point, I already know the x coordinate of my turning point, because my turning point, its x coordinate is always going to be the one right in the middle. Now if I have two intercepts, my thing is going to look roughly like, kind of like this, where my axis of symmetry is the x coordinate of my turning point. So if I know the x coordinate, I can find the y coordinate by subbing my x coordinate into my equation of my parabola into here. So what I'm going to do for my turning point, I already know the x coordinate is 1. So I'm going to substitute 1 into y equals x outside of x minus 2. So putting 1 in place of x, of the x's here, that's going to give me 1 times 1 minus 2. Now 1 minus 2 gives me negative 1. So 1 times negative 1 gives me minus 1. So my turning point is at 1 minus 1. So now I have all these pieces of information here. I have a turning point, I have an axis of symmetry, and I have intercepts. And let me just draw in my turning point here. So my turning point's going to be down here, and this is a minimum turning point because this is a concave up parabola. So my turning point is 1, negative 1. And now I can draw a really nice parabola. So my parabola is cutting my y and x axis at 0. It's going down to this minimum, and it's coming back up and cutting through at x equals 2. So I have drawn now my parabola of y equals x outside of x minus 2. And it's a much nicer drawing because I have more information. The more information we have, the less kind of sketchy and weird our drawing's going to be. Even if you compare this to the ones in the previous video, there's a lot more information and my thing is a lot easier to read. So now we're going to move on to one last final question, and this one is a little bit trickier in the sense that we have a little bit more to do. So we have my y equals x squared plus 2x minus 8. Now, remember our first step is always to factorize. We want this as some kind of binomial product or any type of product. So factorizing is the first thing I want to do here. Now, I'm going to do this factorization a bit quicker because we've already covered this a lot in depth in the first half of this video. Sorry, not this video, course. So please go back to those videos where we talk about factorizing mnemonic quadratics and solving these equations. So I'm going to do this a bit quicker. So I want my two factors to sum to give me positive 2 and to multiply to give me negative 8. So I can set up my product sum factors thing here. So I want two numbers that multiply to give me negative 8 and add to give me positive 2. And those are going to be 4 and minus 2. Minus 2. So this guy here is going to become y equals x plus 4, x minus 2. So just to save time, I've gone straight into this, but please look at the following videos if this is new to you. This is just a video on using what we've already learnt in order to sketch up some parabolas. So now that I have my nice equation here, I can find my y-intercept. That happens when x equals 0. So I'm going to get y equals 0 plus 4 multiplied by 0 minus 2. So this is the same as 4 times minus 2, so that gives me minus 8 here as my y-intercept. Now for my x-intercept, that's not what I want. My x-intercept, we want to let my y equal to 0. So I'm going to have 0 equals x plus 4, x minus 2. And I want to use my null factor law. I'm going to go through this quicker because we've done plenty of examples on this in the past. So I want cases where x plus 4 equals to 0, and the value of x that makes x minus 2 equals 0. So for this one, solving the equation, I'm going to get x equals minus 4. Solving this one, I get that x equals 2. So now I have my x-intercepts. And before we do the next part, I'm just going to draw up my axis now. Axes, I should say. And I have this thing here. So I can start to think about where my points are going to go. So I have a y-intercept of -8, and I have an x-intercept of 2, as well as -4. Let's label my x-axis 2. And now I want to find the axis of symmetry. So the axis of symmetry is going to be the average of these two numbers. The axis of symmetry. So I'm going to get, because I want an x value, I want to see where along this horizontal line where is my middle going to be. So I'm going to get that x equals the average of -4 and +2. So I do -4 plus 2 divided by 2, divided by the number of numbers I'm adding. And that's going to give me -1. So -1 is smack bang in the middle of these two. -1. So I'm going to draw up my axis of symmetry at x equals -1. And now I also want to find a turning point. So the x coordinate of my turning point is going to be where the axis of symmetry lies. So I know that I'm expecting an x value of -1. So I'm going to substitute that into my equation of y equals, what was it, x plus 4, x minus 2. And my turning point, my y coordinate happens when x equals -1. So my y is going to equal -1 plus 4 times by -1 minus 2. So this gives me 3 times -3, which gives me -9. So therefore, let's do that in a different color. Therefore, my turning point is at -1, -9. So that's going to be kind of all the way down here. -1, -9. And now I have all of the necessary information to draw up my parabola. Now it's going to cut through all these points. It's also going to cut through my y-intercept. And now it is just a matter of connecting the dots. That's already looking shocking. So we have this parabola here. And I have shown all of the key features. I've shown the intercept at -4 and -2 for x. I've shown my axis of symmetry at x equals -1. And I have shown my turning point down the bottom as well as my y-intercept. So this, and also we have a concave up parabola. So this is a minimum turning point. So this is the culmination of everything we've been working up until. We've now looked at applying all of the quadratic factorizations we've done, the solving quadratic equations, the x and y intercepts that we learnt from linear relationships, as well as just some regular parabola sketching. And now getting a lot more information, which is going to enable us to draw a much better and clearer picture. That brings us to the end of quadratic equations and parabolas. Thank you so much for joining me, and I'll see you in the next series.